students, this is Vani working as assistant professor in physics in Siddhartha Institute of Science and Technology. Today we will discuss a topic of interference. Interference is studied in the part of optics. Optics is the study of wave nature of light. Optics is the study of wave nature of light. That means the light travels in the form of waves. The light travels in the form of waves. Interference is the first proof for the wave nature of light. Interference means when two light waves superimpose, the resultant amplitude or intensity in the region of superposition is different from the amplitude or intensity of individual waves. That means formation of maximum and minimum intensities by superposition of two identical light rays is called as interference. In one word we can say interference is the superposition of light rays. So what is meant by superposition? Then we discuss a principle of superposition. Superposition means when two or more waves overlap. The resultant displacement at any point and at any instant is the sum of the displacements of individual waves. So that the resultant displacement is the sum of the displacements of individual waves. That means y is equal to y1 plus y2. So y1 is the displacement of first light ray, y2 is the displacement of second light ray. The sum of these two displacements gives the resultant displacement, that is the displacement, that is the principle of superposition. So the principle of superposition is involved in the interference. Interference is the principle of superposition. So that interference is divided into two types. One is constructive interference, another one is destructive interference. Constructive interference, next one is destructive interference. Constructive interference means when the resultant amplitude is the sum of the amplitudes of individual waves. Amplitude means the resultant, the maximum displacement is called as amplitude. Here in constructive interference, the resultant amplitude is sum of amplitudes of individual waves. So that type of interference is called as constructive interference. Next, coming to destructive interference. Destructive interference means the resultant amplitude is the sum of the resultant amplitude is the difference of amplitudes of individual waves. Resultant amplitude is the difference of the amplitudes is called as destructive interference. That is seen as here two light rays we are taken. This is a first light ray, this is a second light ray. The sum of these two will form the maximum amplitude curve. That means that interference is called as constructive interference. What happens here means, here one light ray of same phase, we are taking the next light ray also in same phase. These two will combine means the resultant is coming with a maximum amplitude. The resultant is coming with maximum amplitude and maximum intensity. This type of interference is called as constructive interference. Coming to destructive. So here two light rays we are taken. The overlapping of these two will get the resultant intensity curve like this. That means zero intensity here. Why? Because here the individual waves that taken two light rays are in out of phase. This first light ray is one phase, second light ray is in another phase. These two will combine, then the resultant ray is coming with zero intensity. This is called as destructive interference. Why? Means in constructive interference we observe a maximum intensity. In destructive interference we observe a minimum intensity, minimum and zero intensity. So why? Because here these two light rays are in same phase. That's why it's coming with maximum amplitude, maximum intensity curve we observe in the constructive interference. In destructive interference, these two are overlapping with out of phase. They are not in same phase. That's why the resultant is the zero intensity. This is the constructive and destructive interference. Next topic, conditions for interference. So, what are the conditions to form the interference? First one is the sources must be coherent. The two light sources must be coherent. That means they have to maintain a constant phase. Coherent means a constant phase. Next, the two sources must be monochromatic. Monochromatic means have a single wavelength. Next, the distance between the screen and slit is large. Distance between the screen and taken slit is large, and the separation of two slits is less. This is another condition. Next condition, the background should be black color. These are the conditions to form the interference pattern. In the case of thin film, we can observe the interference. So here we are taking a thin film. In the case of thin film, we can observe a interference pattern like this. Okay, now, so when the light ray falls on that film, the two reflected rays are coming from that film. One is from inner surface, one other one is from upper surface. The two light rays will superimpose with each other, forms the interference pattern like this. So this is the case we observe the interference. So next, applications of interference. So where we observe means interference, the colors in the soap bubble. The colors are due to interference between light rays reflected from front and back surfaces of a thin soap film, making a bubble. Next, the colors change as we view peacock's feather from different angles. In this case also we observe the interference. By using interference, we can find the radius of curvature of a lens. In Newton's rings experiment, we find the radius of curvature of a lens. At the same time, we find the wavelength of light source. Lambda value is also calculated, and then smoothness of the glass plate also calculated. So this is about interference. Thank you.